The last stage of the field data workflow is assimilation, where we validate, assimilate, and back up data. Now, validation is not something we wait till the very end of the project to do, because if we're making an error while we're collecting the data by not collecting the right data or collecting the data in the wrong place, we want to know at the very beginning of the process. If we wait at the very end of the project, validate the data, and discover that error, we might have to throw out the entire field data collection effort, or we might have to redo the project. So you want to make sure that you review field data on a daily basis. Are the spatial features accurate and complete? I like to look at the spatial features, zoom to the entire extent, make sure that there are no gaps or too much overlap, or maybe I accidentally collected the same area twice. I like to open the attribute table and sort the values to make sure that they are also correct and complete. I'll sort them in ascending and descending order. Typically, when you do that, you can see anomalies or null values that shouldn't be there kind of pop up to the top. Then I'll also make sure that my spatial and attribute data are consistent. This is really important when you have multiple teams collecting data or you're collecting data over multiple sessions, because you do not want variations in the way that data is being collected to affect the quality of the overall data. So you want to make sure that everything's consistent. And if it's not, you need to go back to that team member, for example, and train them again on field data collection so they're collecting it the same way as all the other teams. Now, the screenshot on the right-hand side that shows ArcGIS Pro Desktop shows a web feature layer loaded from ArcGIS Online, the tree survey your name layer, on a map overlaid on ortho imagery so that you can compare the features that were collected against the imagery in the background. So this is an example of validating the spatial features. You can also see that I have the attribute table open and I'm looking at the attributes to see if there's any missing attributes. Now, in addition to validating the data on a daily basis, you want to make sure that you're preparing for the next field data session. And so at the end of each day where you collect data, you want to inspect the equipment, make sure that it's all sound. You want to make sure that all the batteries are charged, and you want to get organized for the next day and have all your equipment laid out. So when you come in to the office, you can collect your equipment and head to the field and you're not missing anything, or your batteries are not dead. So you really want to make sure your equipment's in order, your batteries are charged, and that you're organized. Now, field data assimilation occurs back in the office, and that's often where we assimilate the data. It's very important that you preserve the unprocessed raw field data and that you don't manipulate it, because if there's an error in the way that you're assimilating the data, you always want to go back to the unprocessed raw field data. So for example, in this tree survey project that you can see in the Windows File Explorer screenshot on the right, I have a source data folder, and then in the source data folder, I have folders dated for each data collection effort. And I do that because that's where I store the raw data. And then as I process the data, for example, as I convert it to different format, or I transform the coordinate system, or I'm finalizing the data, I do that in the project geodatabase. So if there's an error, again, I can always go back to the unprocessed raw field data. So you really want to make sure that you're validating and assimilating your data often. Don't wait till the end of the project, because if you find a flaw in your process at the very end of the project, you might have to redo the entire project. The last step in field data assimilation is backing up your data. And we talk about this all the time in GIS, but it's even more important in field data collection. And that is, you need to back up your data early and often, so that if there's something that is a mistake in your data or your data gets corrupt, you can always go back and utilize that data. And I like to store my backups off-site, not just put them on a thumb drive on the desk next to my computer, because what happens if, for example, I can't get into the building when I need to, or if something big happens like the building burns down. If I'm backing it up off-site, preferably, for example, in the cloud, then I can still access that data and recoup any investment that I've made in that. You also want to maintain and store daily field logs. Field logs keep track, for example, of each day, each session, the equipment that you utilized, the settings that you utilized, and any characteristics of that data collection effort. And you want to do that because sometimes when you get back to the office, it gets confusing about your raw data and which one goes with which days. And you can utilize your daily field logs to reconstruct your data collection effort. Last, You always want to archive your data at the very end of your project. So not just back it up, but you want to spend a little time cleaning it up, making sure it has standardized names, for example, in your feature classes, but also that everything has proper metadata so that you can come back to this data at a later date. And I guarantee you, you will. There's a lot of times in your career that you'll pick up a project 2 or 3 years later to update it. And if you've made the effort to archive your data, it's very easy to pick up where you left off. Or, for example, you're paying it forward because you have moved on, but somebody else is picking up the project and they really appreciate the fact how easy you've made it for them to pick up the project where you left off. So make sure you archive your data. Now let's review our performance criteria. At this point, you should be able to describe the field data collection workflow, which is to plan, configure, collect, and assimilate your data. You should be able to explain how to plan and configure a mission to increase your proficiency, minimize errors, and improve your data quality. You should be able to list types of feature level metadata collected with GPS. For example, what your GPS status is, whether it's DGPS, 3D GPS, what your estimated positional error is, or your PDOP at any time that you've collected positions. You should be able to explain how to validate, assimilate, and back up field data once you're back in the office. And last, in the demo, exercise, and project, you'll collect spatial features and attribute values in the field.